Imagine a tremendous troupe played by a perpetual number of stars, planets, and moons, all performing together superbly. In any case, there is one explicit fragment of this orchestra that has flabbergasted space specialists for a seriously lengthy time span: exoplanets. Exoplanets are ordinary planets that exist outside our planetary framework, hidden away somewhere deep in the Milky Way. You might be amazed to find that among the huge number of galactic objects, there are exoplanets so similar to Earth, so tantalizingly familiar yet perplexing, that they might be our planet's divine twin. We dive into the charming realm of Proxima b, found just 4.2 light-years away. The James Webb Space Telescope is revolutionizing our mission to understand these cosmic mysteries. Imagine, for a moment, your mind venturing across the vast expanse of our reality. The Milky Way, home to more than a quadrillion exoplanets. That is a number with 15 zeros. To put this into perspective, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We would have enough to create a new landmark on Earth, a Grand Canyon 2.0 that would stretch for an enormous distance. What's even more astonishing is that around 20% of these wonderful bodies have been designated as Earth-like in terms of geology and atmospheric structure. That means there is a 1 in 5 chance of discovering a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our moon, trapped in gravitational dances with their parent planets. If you were to contemplate finding another celestial body that harbors life, or could do so, the universe offers a flood of possibilities. Now that we have laid out the grand scale, it's time to introduce the master expert prepared to paint its complex nuances, the James Webb Space Telescope. This celestial Sherlock Holmes, with its magnified central lens replaced by adjustable optics, surpasses even the most advanced optical instruments. We're not just talking about any telescope. It boasts a 6.5-meter primary mirror, 2.7 times larger than Hubble's. Imagine the incredible detail it can capture, even from the faintest glimmer of a star billions of light-years away. Not only can it observe planets orbiting those stars, but it can also analyze their atmospheres. What makes the James Webb Telescope revolutionary isn't just its observational power, but also its cutting-edge technology, including advanced sensors and spectrographs. These tools do more than simply observe. They can analyze and filter the unique light signatures emitted or reflected by celestial objects, deciphering their atmospheric composition, chemical balance, and even mass. Functioning like a cosmic detective, the telescope can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the capability to answer these questions, elevating it from a mere observer to a scientific genius. It's not just an improvement over Hubble, it's more like a quantum leap. If Hubble's discoveries amazed you, prepare for an era of breathtaking revelations. As we extend our gaze across the intricate tapestry of the universe, it's worth focusing on one particular star in this cosmic symphony, Proxima b. Since its discovery in 2016, this enigmatic planet has stood out like a Shakespearean legend, filled with complexities and contradictions, astonishing both astronomers and astrobiologists alike. What's the big deal? For starters, Proxima b is practically in our cosmic backyard, just 4.2 light-years from Earth. To put that in perspective, if you could travel at the speed of light, you would arrive in just over 4 years, the same amount of time it takes for your favorite TV show to fall into reruns. But let's dig deeper into why this proximity is so significant. We're talking about a universe that spans over 93 billion light-years across. Finding a planet so close and so promising for scientific research is like discovering a diamond in a mountain the size of Everest, a gem that could hold secrets about life itself. In the grand weave of the cosmos, Proxima b is a crucial thread, offering us valuable clues that could redefine our understanding of habitability and life beyond Earth. It's not just Proxima b's proximity to Earth that excites researchers, but also the tantalizing signs that this planet isn't just Earth-like. It could be Earth 2.0. Proxima b sits comfortably in what astronomers call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, winding rivers, vast lakes, and possibly oceans as deep and mysterious as the Mariana Trench. However, before we dream of traveling to Proxima b, we must consider a few of its peculiarities. For one, a single day on this fascinating exoplanet lasts a staggering 11 Earth days. Imagine sunrises that not only mark a new day, but unfold slowly, resisting the rush of noon, while sunsets linger, creating golden hours that photographers could only dream of. While this sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adapt to these prolonged cycles of light and darkness? Would we need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way? The fundamental patterns of life, as we know them, would be both tantalizingly familiar and eerily strange. It's as though nature is presenting us with a paradox wrapped in a mystery, challenging our understanding of what makes a planet livable. You may wonder how we can gather precise and reliable data about a world we have never visited. The James Webb Space Telescope deploys all its capabilities like a giant Swiss Army knife. It's more than just a telescope. It's a sophisticated research lab floating in the vacuum of space. Thanks to its innovative technology, astronomers don't just observe planets. They examine them through a scientific lens that would make even CSI labs seem simple. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By studying these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible presence of life-essential compounds, such as water, organic carbon molecules, and even oxygen. This is not just astronomy, it's cosmic forensics. We don't passively wait for clues to come to us. We actively seek them, investigating the particles and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky. It's a highly specialized research lab, a scientific detective, and a cosmic investigator all in one. It allows us to transform our theories and speculations about alien worlds into concrete methods to confirm or refute them, revolutionizing our understanding of what might exist beyond our pale blue dot. As we venture further into the great unknown, Proxima b remains a tantalizing beacon of possibility. But the mysteries do not stop there. The James Webb Space Telescope, with its unparalleled precision, is not just gazing at one exoplanet. It is unraveling the secrets of countless worlds scattered across the universe. Consider this. Among the quadrillions of planets, some may harbor alien oceans stretching endlessly beneath thick atmospheres, while others might be encrusted in ice, concealing vast, subterranean seas warmed by internal heat. Some could be wrapped in toxic gases, inhospitable to life as we know it, while others may possess just the right blend of elements to foster biology in ways beyond our current understanding. With each passing observation, Webb brings us closer to answering one of humanity's greatest questions. Are we alone? The hunt for life. In the vastness of space, the definition of habitability is evolving. Traditionally, scientists have searched for Earth-like conditions, liquid water, a stable atmosphere, and a hospitable temperature range. But what if life does not require the conditions we assume? Webb is redefining this search by examining exoplanet atmospheres for biosignatures, chemical fingerprints that could hint at biological processes. The presence of methane, oxygen, or unusual chemical imbalances could suggest the influence of living organisms. Even more intriguingly, Webb's spectroscopic instruments can detect these gases with an accuracy never before possible, providing us with clues about potential alien ecosystems. Some researchers speculate that life may thrive in ways we have yet to imagine. Could there be organisms that breathe hydrogen instead of oxygen? Life forms adapted to extreme radiation? Microbial colonies flourishing beneath the icy crusts of distant moons? The more we discover, the more we realize how little we truly know. The cosmic frontier, As the James Webb Space Telescope continues its mission, it is not just exploring exoplanets, it is rewriting our cosmic story. Every pixel of data it captures brings us closer to unlocking the grand design of the universe. Imagine the future, a time when we no longer gaze at the stars wondering if life exists beyond Earth, but instead study alien ecosystems with scientific certainty. A time when missions are no longer theoretical, but planned voyages to distant exoplanets, seeking to touch the worlds that, until now, we could only observe from afar. Perhaps, in the coming decades, humanity will take its first steps into a new chapter of existence. Not as inhabitants of a single planet, but as explorers of the endless cosmos. Until then, we watch, we wait, and we dream. Of this cosmic onion, the story goes off in a strange direction, similar to any science fiction spine chiller. Researchers utilizing the James Webb Space Telescope got something surprising from Proxima b, a signal so astounding that it spread all through the scholastic passages and online entertainment. Named as a potential technosignature, it was an electromagnetic emanation so mind-boggling and intricately planned that it could highlight the presence of an advanced civilization. The aggregate heartbeat of mankind appeared to stop at the peak of a discovery that vowed to reshape our understanding of the cosmos. A transient, divine oddity? An incident of inestimable alignment? Or something else? Purposeful, a coded message, or even an indication of extraterrestrial intelligence. The solitary mission cast a shadow of mystery over Proxima b, igniting fierce discussions and speculation. Was it merely a passing oddity, or is it part of a much bigger story, more intricate than we can imagine? However, wait, the tale of our astronomical investigation is far from finished. The ink has not yet dried, and new chapters are still being written. This time, it is not just ordinary analysts, but Harvard researchers who are driving a shift in perspective in our search for extraterrestrial life. They are not satisfied with merely exploring the signals and anomalies we've observed so far. They are raising the stakes by turning the James Webb Space Telescope into a sort of massive night vision instrument. They aim to search for artificial light sources in both the dark and illuminated regions of distant worlds. We are talking about staggering possibilities, such as detecting glowing urban landscapes in the darkness, like brilliant specks in the void. Imagine seeing the shining lights of what could be a city, humming with the presence of an advanced civilization, its glow transmitting across the vast cosmic ocean. As we continue to unravel the mysteries of our universe, the search for extraterrestrial life takes on new dimensions. Beyond the immediate interest in Proxima b, our grand pursuit delves deeper into the vast, uncharted regions of space. This mission is driven by both technological advancements and a profound curiosity about our place in the universe. Continuous breakthroughs in cosmology and space exploration have led to the discovery of numerous exoplanets with potential habitability. Instruments like the James Webb Space Telescope, biomarkers, and ground-based observatories have expanded our ability to detect and study these distant worlds. One particularly intriguing area of study is the search for biosignatures, signs of life. These could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, could suggest biological activity. The JWST's capabilities extend beyond simple detection. Its advanced instruments can measure the atmospheric composition of exoplanets with remarkable accuracy. By studying starlight that filters through an exoplanet's atmosphere, researchers can identify chemical markers indicative of life. For instance, the presence of water vapor alongside other key molecules, such as oxygen or ozone, could point to the potential for life-supporting conditions. Another avenue of exploration involves studying the environments of these distant worlds. Climate models, based on data from JWST, can help predict whether an exoplanet's conditions could support liquid water, an essential ingredient for life as we know it. Scientists are particularly interested in planets located in the habitable zone of their parent stars, where temperatures could allow for stable liquid water. The search also extends to the moons of exoplanets. Some of these moons, particularly those in the habitable zones of their host planets, could have conditions suitable for life. For example, icy moons in our own solar system, like Europa and Enceladus, are believed to harbor subsurface oceans beneath their frozen crusts. Similarly, moons orbiting exoplanets could present analogous conditions where life might exist. Beyond biosignatures, the concept of technosignatures has gained momentum. These are indicators of advanced civilizations that might be observable through artificial structures or technologies. This could include megastructures like Dyson spheres, hypothetical constructs designed to harness a star's energy, or unusual patterns in radio transmissions. As we refine our global collaborations and observational methods, the search for technosignatures could reveal the presence of extraterrestrial intelligence. In addition to technological advancements, global cooperation plays a crucial role in the search for extraterrestrial life. Collaborations between space agencies, research institutions, and private companies enhance our ability to explore space. For example, missions to Mars and other celestial bodies involve contributions from multiple countries, pooling resources and expertise to achieve shared goals. Public engagement and education are also vital aspects of this mission. The excitement surrounding space exploration inspires the next generation of scientists and engineers. Outreach programs and educational initiatives help foster interest in STEM fields and encourage young minds to pursue careers in space science. The development of new technologies also contributes to our understanding of the universe. Advances in telescope design, data processing, and computational models improve our ability to detect and analyze distant exoplanets. For example, next-generation space telescopes like the upcoming Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HabEx, are poised to provide even more detailed insights into the habitability of exoplanets. As we push the boundaries of our knowledge, each new discovery raises further questions and areas for exploration. The search for extraterrestrial life is not just about finding alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our knowledge and expands our understanding of what it means to be alive. In conclusion, the exploration of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With each advancement, we move closer to answering some of humanity's most profound questions. As we continue to explore the universe, the possibilities for discovering new forms of life and understanding our place in the cosmos remain boundless.